Okay, today we're looking at Lesson 5-3 on page 126, Greatest Common Factor. This is probably something you've seen before last year. All right, so the question is, how can you find the greatest common factor, or the GCF, of a set of numbers? Keisha is putting together bags of supplies. She has 42 craft sticks and 12 glue bottles. If she puts an equal number of craft sticks and an equal number of glue bottles into each bag, what is the greatest number of bags Keisha can make so that nothing is left over? So they're dividing these craft sticks equally into a certain number of bags, we don't know how many, and then also these glue bottles. Not necessarily the same number of craft sticks as glue bottles, just equal numbers in each bag. All right, so let's look at the next page. All right, one way to find the greatest common factor is just to list and compare all the factors of each number in the set. So we would take factors of 12 and list them. And you have to be careful not to miss any. So 1, of course, is a factor of 12 because 1 times 12 is 12. 2 is a factor of 12. Remember those divisibility rules. If 2 can go into 12, obviously it's a factor of 12, and 12 is an even number. So 2 would be a factor. 2 times what would get me 12? Well, 6. So I know that's a factor of 12. 3 goes into 12. Again, divisibility rules, but you probably just automatically know that because 3 times 4 gives you 12. So these are all the factors of 12. Notice that the last factor other than 12 itself here is 6, which is half of 12, and you'll find that's just the pattern. You'll have factors until you get to half, and then the next factor will be the actual number itself. So then you have to do the same thing for 42 in order to compare them. So 1 is a factor of 42, because 1 times 42 will get me 42. 2 is a factor of 42, because again, I'm looking at the ones place, and it's an even number here. So I know 2 will go into that, and if I split 42 into half, or divide by 2, I would get 21. So 2 times 21 gives me 42, so these are factors. 4 plus 2 is 6, and 6 is divisible by 3, so I know 3 is a factor of 42. And that means 3 times 14 will give me 42. 6 is a factor of 42 because 6 times 7, which is the other factor, will get me 42. Notice again, I have 1, 2, 3, 6, 7, 14, and then 21, which is half of 42, and then I'm done finding factors except for the number itself. So, they share these factors. Number 12 and 42 share these factors. 1, 2, 3, and 6 are factors of both 12 and 42. So they would be called common factors. All right, so remember, the greatest common factor is what we're looking for, is the greatest number that's a factor of both of those two numbers. And you can see that 6 is the largest or the greatest common factor of 12 and 42. So this means that 6 is the greatest number that can be divided evenly into 12 and 6. So she can make 6 bags. She can divide those sticks and those glue, the glue and the sticks into 6 different bags evenly. That would be your answer. Alright, so one way to find the greatest common factor is to list the numbers like I showed you with this last example. But you can actually use the prime factorization of the numbers to find the greatest common factor. And that actually is easier when you start to use larger numbers or when they give you 3 numbers. So on this another example here, it says find the greatest common factor of 60 and 84, larger numbers. So if you use a factor tree and find the greatest common factor, or the prime factorization of 60, and use a factor tree to find the prime factorization of 84 and compare those, you can find the greatest common factor. So they skipped making the tree and they go right down here for both of these, and they write the prime factorization of 60, which is 2 times 2 times 3 times 5, or they can write it with exponents here. And for 84, it's 2 times 2 times 3 times 7, or with exponents here. So what you're doing is you're looking for the common prime numbers here, and then you can multiply those together. But you can only use what they both have. So if you look at 60, it has 2 times 2. So that means it had two twos in its prime factorization tree. And so did 84. So you can use those. And so you can use 2 twos, not 4. You don't use all of the sets, just 2. And they both had a 3. So you can use the 3. But then we have a 5 and 60 and a 7 and 84, and you don't use those. So you multiply the common prime factors, which is, if you look over here, 2 twos, or no, it's not all of this together. This is the equal sign. Here's 2 twos on this side. So they both have 2 twos in their prime factorization, so you can use it, right? Here's my 2 twos, 2 twos for 84. And then they both have a 3. And if you look at that here, that's why we're multiplying by the 3 there. So when you multiply that together, 2 times 2 is 4, times 3 is 12. So you'll find that the greatest common factor of 1684 is 12. I want to show you that again doing my factor tree. Hold on just a sec. Okay, so let's do this again. 60 and 80 were our two numbers, and we're trying to find, oh, not 80, hold on, 60 and 84. Let me do that right. 60 and 84 were the numbers in this another example. So what you would do first is actually make your tree. Let me just start with 60, and I'm going to go with 6 times 10 is 60. And of course they're not prime, so I'm going to keep working. 2 times 3 is 6. I'm going to circle these because they're prime. 2 times 5 would get me 10. Okay, again, I'm done with my prime numbers. And let's go over here to 84. So I'm going to do 2 times 42 gives me 84. I'm going to stop there with that 2, and I'm going to keep on going. And 2 times 21 is 42. Now you may have started with different factors, and that's okay. 3 times 7 is 21. Both are prime, so I'm done. Alright, so now you're going to compare, and you're going to say, see, what is similar over here, which factors are similar or the same over here, that 60, that are the same over here on 84 that I can use. And I see that I have 1 2 and another 2. And I have 1 2 and another 2 over here. So because both sides have 2 2's, I can use, oops, hold on, I can use 2 2's. Alright, so I know it's going to be 2 times 2, and I look again. I have a 3 over here. Do I have a 3 over in my factor tree on 84? Yes, I do. So I can use my 3. 1 3. Notice I don't put 2 3's down here. It's only as many as are in both. Okay, I don't double it up. And then I have the 5, which I do not have over here on 84. And I have a 7, which I do not have over here on 60. So this is how you find your greatest common factor. 2 times 2 is 4, times 3 would give you 12. So that will be your greatest common factor. Okay, let's look at the guided practice, page 126. Number 1 is 18 and 36. They want you to find the greatest common factor for these two numbers. So one way to do it is list the factors. And I can do it quickly. It might take you guys more time. I'm going to show you both ways, but factors of 18, I would list 1. So 1 times 18 gives me 18. 2, because 2 times 9 gives me 18. 3, because 3 times 6 gives me 18, so I'm going to go ahead and put 6 down, my 9 down, and my, oops, 18, a little messy there. 36, I have 1, 2, it's even, so I know that's the case. 3, because 3 plus 6 is 9, and it's divisible by 3. 4, I know 4 times 9 is 36. 6, because 6 times 6 is 36. There's my 9. 12, that would be 3 times 12. My 2 times 18, and then that's half, so again I go to 36. And if I look at that, I can see 18 and 36, or 18 and 18 are the greatest common factor. If you chose to do a factor tree, which I really think becomes the easiest way once you get these bigger numbers, just do your factor tree like you normally do. So I started with 2 times 9, 2's prime. I branch off of 9 with my 3 times 3, and I'm done. It becomes so easy. I think I'll do 6 times 6 here. Branch off of each of these with 2 times 3, and those are all prime here. And I just compare my prime factors. On this side, I have a 2 as far as 18 goes, but 36 has 2 2's. So how many do I get to use? Only as many that they have in common. They both have 1. 36 has 2, but 18 does not. So I can only use as many as both have in common, which would be just 1. So I have 2 times. Now I have 2 3's over here. Do I have 2 3's with 36? Yes, I do. So I can use 3 times 3 here, or 3 squared. So I could write it that way, or I could write 2 times 3 squared. Either way, it's 2 times 3, which is 6, times 3, which is 18. So I know that 18 is going to be the prime, or the greatest common factor of 18 and 36. And some of you may have known that 18 was half of 36 and got it without really even having to work that hard. Okay, number 2 on that page is 14 and 35. All right, I know that 1, 2, 7, and 14 are factors of 14, and 35 I know 1, 5, 7, and 35 are factors, and so if I look at this, I'd circle my 7's here. But if you did the factor tree, now notice I'm listing quickly because I've thought about this and I already know it. It might take you a little longer and you have to spend more time listing. So if you go to your factor tree, it might be a little easier just thinking of the 2 factors you know that you can multiply together to get that. So 14 has 2 times 7, and 5 really just has 5 times 7, both prime numbers. Which numbers do they have in common? Each of them have 1 7, so the greatest common factor of these 2 numbers is 7. Last one I'm going to do with you, or maybe you should do, and then pause me and try it yourself, is 22 and 55. Try listing, see how fast it is, and try the factor tree and see how fast it is. And then push play, and I'm going to go ahead and go. For 22, I have 1, 2, 11, and 22. For 55, I have 1, 5, 11, and 55. So I can see my greatest common factor is going to be 11 here. If I did the factor tree, just as easy and really faster if you have to really think about listing those factors. So I have 2 times 11. Both are prime. So I stop there. And 5 times 11. Both are prime. So I stop there. And again, I can only use what they have in common, which is 1, 11. So I can only use 11 one time, which means that is the greatest common factor. Okay, you guys go ahead and start your homework, which would be to finish and do 4, 5, 6, 7, and 8. And go ahead and think about question 9. Why can the greatest common factor also be called the greatest common divisor? And then how are the 2 ways shown to find the greatest common factor for a set of numbers alike and different? You know what, don't do 10. We'll talk about it in class, but definitely try to answer number 9 and come to class with a question. And I'll see you tomorrow.